Good morning, class, and welcome to math. Today is Thursday, April 23rd, and we are just continuing on with graphing. Take a deep breath. Today is going to be an easier day for math, so recover from yesterday, which was really challenging, and let's get started. Whoops. And of course, I forgot to pass, but we can do a quick review of everything that we've done this week. So we have really been focusing on graphing on the coordinate plane, which remember the coordinate plane. Let's do a little bit of review first. So remember, my dog was really scared by that our coordinate plane looks like this. And this is a place where we can just graph numbers and see trends. Anything that is on this graph is a point. When we have an ordered pair, it always goes x, comma, y. And what that does is it gives us two sets of GPS directions. X goes to the left and right, Y goes up and down. This is quadrant 1, 2, 3, and 4. Okay, so in these 4 quadrants, we know a couple properties. Anything that's in quadrant 1 is going to be positive, positive. And the reason for that is because positive X tells me to go to the right, positive Y tells me to go up. So in quadrant 1, all my ordered pairs are going to be positive, positive. In quadrant 2, all of my ordered pairs are going to be negative, comma, positive. And the reason for that is because if I have a negative X, it's telling me to go towards the left. And if I have a positive Y, it's telling me to go up. Anything that's in quadrant 3 is going to be negative, negative, opposite of 1. And that's because anything on my X that's negative is telling me to go to the left. Anything that's negative on my Y is telling me to go down. And in quadrant 4, this is going to be positive, comma, negative, because positive X is to the right and negative Y is down. So that's just a little bit review of what we were doing. We also talked about patterns and tables. So we talked about how we could have an XY table and it could give us values. So for example, 2, 4, 3, and this 2 is backwards. Something, 8, something, and then say 5, 10. And what we need to do to answer a question like this is figure out how do I go from my X to my Y. And we show that it should be the same for everything within this table. So 2 plus 2 is 4. 2 times 2 is 4. So now I need to see which of those will work for my other ordered pairs. So 5 plus 2 is not 10, but 5 times 2 is 10. So I know my rule for this particular data table is going to be times 2. Okay? So that's just a review of our coordinate planes and everything that we've been talking about all week. So if you have any questions about that, make sure you ask me. So our Bunny Hill today asks us, what are some examples of real-life situations that require graphs? Mention at least 3 examples. Why is graphing important? My expectation is that you write a good race paragraph for your Bunny Hill. I really want to see some good writing here, and I want you to really think, what situations do you use graphs for? For me, I actually use graphs all of the time. And I'm going to give you a couple of real life examples that I use in my life with graphing. And let's see. So for example, you might use graphs to see which areas are most crowded when you go to an amusement park. Some amusement parks have literal graphs of bar and pie charts that show you which rides are going to be the busiest, which rides are going to be not the busiest. I use graphs the most in my life to chart your progress. Every test you take, I'm always looking at those graphs to see how you did, especially when I'm comparing how did I teach compared to the district, compared to the state. What things are we strong in? What things are we not strong in? I also use graphs, for fun when I'm looking at how many people attended concerts or how many people can fit in a certain venue or things like that. So graphs are a part of my everyday life. They're on the TVs when I'm looking at statistics about the coronavirus. They're on political debate stages, talking about different statistics. So, like it or not, data and statistics are a permanent part of our lives, and the more computers are used, the more data and statistics are going to be really important. So it is very important that you use this to figure out how to use graphs. Okay, so make sure you write a great paragraph. I'm going to show you some answers to get you started. So data is used all around us, therefore requiring graphs, answers will vary. Some examples include calculating sales, number of participants, science experiments. Oh, I forgot about that one. Yeah, we use science experiments data all the time. Attendance, we do a graph for that every day. Growth, or literally anything that uses data. So think about what uses data and how you can fit that into a good paragraph. Okay, so our hot cocoa break gives us a fun scenario. Damien and his family are at Disney World. Do not worry if you have not been to Disney World at all, by the way. I did not go until like last year, so it took me a while too. All of a sudden, Damien gets really hungry while he's waiting in line at Pirates of the Caribbean ride. Each of the letters represents a snack stand. Answer the questions with the correct letter as well as the coordinates. So which stance is closest to the Pirates of the Caribbean ride? Which of the snack stands is furthest from the Pirates of the Caribbean ride? And assuming each of the squares is equal to 5 square feet, and then you go south 10 feet. Wait, if you go south 10 feet, then the same number of feet west, which snack stand would you be at? So the first most important thing for us to understand is that sun in the middle of your screen, that represents the Pirates of the Caribbean ride. So whenever we get a question like this, you always want to look at where am I starting at? That should be the very first question you ask yourself, because knowing where we start is a little different here. Before, when we were doing the coordinate plane, we always started in the center, which is also known as the origin. For these kinds of questions that are more using graphs to show distance and spatial relationships, we are going to represent this with a symbol. I'm going to do my darnest to recreate this particular situation. Let's see how I'm doing so far. So this is our coordinate plane, just like I was talking about before. Usually when we're graphing, we start at the origin, right? Which is this 0, 0 in the center. This star that you see on your screen represents the Pirates of the Caribbean ride. Let's see, then there's a C, which I already did backwards. Then there is B, and then we have E, then we have D, and F, and then we have A and G. By the way, if you have your Ultimate Math books at home, I really want to see you attempting to do this with me on your graph paper. I'm doing the best I can to recopy it. So, the first question says, which of the snack stands, so each of these dots represents a different snack stand, are closest to the Pirates of the Caribbean ride? So right now, just looking at my makeshift graph, I'm hypothesizing that it's B. My second choice would probably be D or C. So I'm going to check those out. So I want to see how many lines I have to go across to get to B. So that would be 1, 2, 3 for B. So I'm going to write that down. B equals 3. Let's see how many for C. 1, 2, 3, 4. And it's important to note that you count each direction. You can never go on a diagonal. So you need to go like 1, 2, 3, 4, like that. You cannot go like that on a diagonal. So my C was equal to 1, 2, 3, 4. So I'm going to write C equals 4. So far, my B is the closest. Let's try D. D is 1, 2, 3. Oh, that's interesting. It seems like we have a tie. So for this one, what I would say is that I can see here that B and D are both equal to 3 spaces away. So both of those are correct answers. Number 2, which of the snack stands is furthest from the Pirates of the Caribbean ride? I'm going to guess G, but let's count it out together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So G is equal to 10 spaces away. Some students actually like to calculate all this before they get started. I don't really like to do that. I like to count it as I go. If I'm looking, the only other one would be E. So E is 1, 2, 3, 4, 5, 6, 7, 8 away. So E is not quite as far. So my best answer for number 2 is G, because I've counted the spaces away, keeping in mind that I have to go on the lines, kind of like how Pac-Man has to follow his little pathway. You cannot go on a diagonal like this. You have to count this way, or any combination of this way. And if you try, all of these are going to be equal. Well, I mean, most of the time. There are other paths that you could take that would be further. Assuming each of the squares is equal to 5 square feet, if you go south 10 feet and the same number of feet west, which snack stand would you be at? So, remember that each of these lines is going to be, I need to go south 10 feet, so 5, 10, and then I need to go west 10, 1, 2. So I'd be closest to both A and B in that situation. Let's take a look at our answers. Whoops. Which snacks, there's 2 more questions. Look at us. Which snack stand is furthest to the east? So again, we're pretending that this is north, east, south, and west. And then, so the furthest one to the east is going to be northeast, southwest, never eat slimy worms, is going to be F, because you see how F is the furthest line to the right, which is the east direction. And then the planners at Disney want to add another snack stand that is at least 15 feet away from all of the other snack stands. Where might they build one? There's actually a lot of options here, so just make sure that you can count 15, 5, 10, 15. Remember, each one is worth 5 away from every snack stand. So this is a little bit tricky to represent on my board. So that's why I'm just going to project the answers. Answers are example. One example is 0, 5. So here are the answers. Hopefully that makes sense. Please feel free to reach out to me if you have any questions, comments, concerns, and I hope you all have a wonderful Thursday.